Welcome to this explainer. Today, we're jumping straight under the hood of the SASB biofuel standard. Look, if you're already in the weeds of analyzing ESG data, you know for a fact that raw numbers, they really only tell half the story. So, to figure out what's actually going on, we're going to use a sleek industrial dashboard setup to decode exactly how this standard normalizes environmental data.
Think about it like this. Imagine you're evaluating two totally different companies in the biofuel sector. On one hand, you've got this massive legacy refinery sprawling across hundreds of acres. On the other, you've got a boutique, highly specialized advanced biofuel startup. Now, if that massive refinery withdraws 10 times more water than the startup, are they actually 10 times worse at water management? Or, are they simply 10 times bigger? How exactly do we compare these apples to oranges without just making a weird fruit salad?
Well, the truth is, if we're just looking at raw, unnormalized environmental impact data between companies of vastly different sizes, we are working with a fundamentally flawed approach. For investors looking for genuine sustainability insights, raw output data is honestly just misleading. A massive facility is naturally going to emit more volatile organic compounds or consume more total metric tons of feedstock simply because of its massive footprint. We absolutely have to measure efficiency, not just sheer scale.
So, to solve this problem, let's boot up our system dashboard. Here's our sequence for today. First, the ESG comparison conundrum. Second, the biofuels dashboard dials. Third, normalizing the performance data. And finally, empowering the smart investor.
Okay, starting with Section 1, ESG comparison, the context problem. To really get to the bottom of this context problem, we can actually look straight at the introduction of the SASB standard itself. They state perfectly that activity metrics exist specifically to quantify the scale of specific activities or operations. They're meant to be used alongside other sustainability metrics to normalize data and facilitate fair, apples-to-apples comparisons. Basically, activity metrics are the vital context that finally gives raw numbers their actual meaning.
Which brings us to Section 2, Dashboard Dials, Measuring Scale.
The SASB standard explicitly lays out three foundational activity metrics that we need to track. They're categorized under the codes RRBI000A, B, and C. And these three metrics? They form the absolute bedrock of our dashboard, because without them, any other sustainability data you're looking at is pretty much just floating in a void. So let's take a closer look at each one of these dials. The very first counter on our digital factory screen is biofuel production capacity, which is measured in millions of liters, or ml. This gauge gives us the ultimate baseline for a facility's potential scale, showing us the theoretical maximum output of the operation. And knowing that absolute capacity is crucial. Why? Because a facility running at, say, 50% capacity is going to have a wildly different efficiency profile compared to one running at 98% capacity. Then, our second tile shifts from theoretical to actual. This tracks actual production volumes, again in millions of liters, but it splits them into four highly specific categories defined by the standard. We're talking 1. Standard renewable fuel, 2. Advanced biofuel, 3. Biodiesel, and 4. Cellulosic biofuel. This breakdown is huge because processing cellulosic biomass, like agricultural waste, has a completely different energy and emissions profile compared to standard renewable fuels. You have to know exactly what's flowing out of those pipes. And our third counter tracks the inputs. It monitors the total amount of feedstock consumed in production measured in metric tons. And there's a really important note in the SASB standard here. This metric strictly accounts for feedstock purchases adjusted for any changes in inventory throughout the reporting period, meaning it's not just about what they bought, it is exactly what was fed into the process. Okay, so we've got our three dials: capacity, actual production by type, and feedstock consumed. How do we actually use them? Let's look at Section 3, Normalizing Data, Performance Context. Here's how all of this builds into our final analysis. The mathematical normalization formula is super straightforward, but man, is it powerful. Step 1. You grab a raw sustainability metric. Let's say thousands of cubic meters of water withdrawn. Step 2. You identify the corresponding activity metric from our dashboard, like total millions of liters of biofuel produced. Step 3. Just divide the raw data by the activity metric. Boom. What that gives you is an accurate intensity rate. Instead of just knowing total water used, you now know exactly how much water was required to produce a single unit of fuel.
So the real magic here is that you can take any raw warning light, whether it's air quality pollutants like tons of NOx, or the percentage of water consumed in regions with extremely high baseline water stress, and mathematically contextualize them against the entity's actual output. Suddenly, that massive legacy refinery we talked about earlier, it might actually prove to be highly efficient per liter of fuel produced. Meanwhile, that tiny startup might be struggling with massive resource consumption per unit. Normalization reveals the actual truth hiding behind raw numbers.
Which takes us to our last stop, Section 4, Smart Investor, Empowering Markets. So why is generating these normalized intensity rates such a game changer for capital markets? Well, by requiring these specific activity metrics, capacity, production by type, and feedstock consumed, the SASB standards enforce a level of fairness and accuracy that just didn't exist before. It allows institutional investors to allocate capital based on true environmental efficiency. It completely cuts through the noise of misleading sustainability claims where a company looks green just because it's small or dirty just because it's large. It shifts the entire conversation from sheer physical footprint to real operational excellence.
I want to leave you with this final thought today. As sustainability disclosures become universally standardized across the globe, the days of companies hiding behind unnormalized raw data are rapidly coming to an end. So, how will this mathematical normalization completely redefine our understanding of true corporate efficiency in the years to come? Thank you for joining me for this explainer, and remember to always look for the context behind the numbers.